I'm Alex Pault, editor-at-large for Electronic Design, and I'm here at the PCIM show at the EPC booth with my good friend and friend of the show, Alex Leto. How's it going, Alex?
Well, it's going very well. It's a lot of fun to be here, post-COVID world.
Well, and that's the other thing. I was initially worried that there was going to be a little bit of a lightweight turnout, but it's turned out to be quite a nice show, hasn't it?
Seems like we're at very good traffic. This is the big day, too, so it's doesn't going to get better than this.
So now, when you think about the way the market's been going, I mean, we did have COVID in the interim. What kind of promise are you seeing with power and power semiconductors? I mean, for the last 10 years, I've been saying power is sexy again, and it looks like people are finally getting it. Power is really becoming the first thing people think of instead of the last thing people think of.
So I think that wide bandgap, which has come of its own in the last 10 years, is the reason that power is sexy, because it enables new things that didn't happen before, new topologies, wonderful new power densities and things like that. So that created the sexy. Of course, that also led a little bit up a hype cycle. And now I think that we're in the pragmatist cycle where things are, people have relaxed a bit, and now they realize it's here to stay, and let's see how to use it best.
Now, what kind of questions are you getting from the attendees here at the booth about wide bandgap? What kind of discovery questions are you getting, or do they understand what's going on and they just want some of it now?
Yeah, I think that a few years ago, it was, people really were on two sides of the fence. GaN is not for me. And the other side was, yeah, I'm thinking about it. And when we did surveys about 3-4 years ago, just pre-COVID, it was 70% of people were not really thinking about GaN. 30% were either using it or thinking about it. And then last summer when we did a similar survey, it was flipped around. It was 70% were either using it or considering using it, and 30% were still in the dark. And they will come around soon.
So that means we're poised for the next generation of development. I mean, I've been telling people that wide bandgap's going to cause a revolution in power electronics. I think we're finally starting to see it manifest.
I think it's accepted. I think it is absolutely accepted. So now the questions always come out is, why not faster? Why not sooner? When is it going to be this or whatever? And the answer really more has to do with the industry's pace of redesign than it does product offering or confidence in the new materials.
Got it. Do you have something here interesting at the booth? I mean, you obviously have interesting stuff, but do you have something you want to show us?
I have a lot of stuff to show you. Where do you want to start?
You take us around the booth, okay?
Let's do it. All right, so here we have the lineup of all EPC's products. There are about 150 of them, and you can see there's packaged parts, wafer-level chip-scale parts, ICs, discrete devices. You'll also notice that there are automotive-certified products and rad-hard products for satellite electronics. And this is just covering a spectrum from 350 volts down to about 15 volts. This is showing the DC to DC world as we describe it with GaN. And really, one of the most exciting things is that power densities have gone up tremendously, and the driving force is AI server applications. So, for example, here you see 3 different kilowatt DC to DC converters, 1,000-watt DC to DC converters. This power density of over 5,000 watts per cubic inch is triple the state of the art a year ago. There's no more expensive real estate than on a server board. So these are 3 different manufacturers, Syntec, which is a Delta company, then there's Flex and MPS, all producing this as a multi-sourced item for server manufacturers. Now, the second thing where DC to DC is soon to take off, because in the automotive world it takes many years, is in DC to DC converters that allow for a 48-volt distribution bus in cars. Here's an example of that. This is actually a 1.7 kilowatt power supply that's used by BrightLoop in not just race cars but also light vehicles. And in production cars, and you'll soon see 48-volt distribution buses on about 13 million mild hybrids in the next couple of years. And now several electric car companies have also announced they're going to a 48-volt distribution bus, led of course by Tesla. Now, as time goes on, there are all sorts of new topologies. One of them is the multi-level converter. And the thing about a multi-level converter is it allows you to use low voltage parts to make high voltage applications. So here's an example of a 3-level converter, which has a 280 volt input, and it has in this case, a 24 volt output. And the thing about multi-level converter is that rather than using high resistance, high voltage parts, you can use low resistance, very low voltage parts and just stack them up like in series. It's a little bit more complex, but once you work out the complexity in your design, it becomes much higher power density and higher efficiency. It's a 99% efficient converter. Solar is our fastest growing market. It went from 0 2 years ago to about 11% of our sales last year. It should be about 20% this year. We're seeing massive conversion to a new generation of solar electronics that live on the panel. Here's some examples. This is a microinverter that lives on a panel, so a solar panel would have this on it, and it has a optimizer on the front end and then an inverter on the secondary side. So what happens is it optimizes the amount of power it can draw out of each solar panel and then sends it onto the power grid. Very small thanks to GaN. The optimizer itself is sometimes attached to the panels, and then the output of the optimizer, which is a DC signal, 30 volts to 60 volts, is then sent down a rail to a central inverter, maybe on the side of the house. Here's one from BRC, and you can see the big advantage that they say of using GaN is it gives them 99.5% efficiency. If you pay all that money for solar panels, you don't want to lose it in your power electronics. This third one is a company, Solar Native, and this is the entire microinverter. It's got the optimizer and the inverter in it, and it fits right inside the frame of the solar panel. Again, very, very efficient and a very good form factor that comes right with the panel. Here we have an in-hub electric bike motor drive, and it's being powered by 3 of our little power stage ICs. And you can see, clearly that this is an immensely simplified way to make a motor drive. Just 3 ICs and a digital controller. And this form factor is good for drones, it's good for scooters. We now have a forklift truck application for these things as well. And I'll make a prediction. All battery operated motors are going to go to GaN.